All right, today we're going to look at graphing quadratics, but in standard form. So we're going to learn how to graph a quadratic in standard form, and then how to transform from standard form to vertex form. So how do you graph in standard form? You got to find your A, B, and C first, and find the value of x for the vertex by using x equals negative b over 2a. You're going to find the y value by subbing that into the x and simplifying. And we're going to find more points from the vertex. We're going to go over 1 and up or down. 1 squared times a, then 2 squared, and then 3 squared like we did in vertex form. So here I have this graph, this equation. My a is 1, my b is negative 4, and my c is 1. So we're going to use x equals negative b over 2a. So negative b, so negative of a negative 4 over 2 times 1 is 4 over 2, which is 2. Then I'm going to plug it back into the 2 into the original equation. So my vertex right now is 2 and something. So I'm going to plug it in for x. So y equals 2 squared minus 4 times 2 plus 1. So 4 minus 8 plus 1 will give us 4 minus 8 is negative 4 plus 1 is negative 3. So our vertex is 2, negative 3. Right here. My a is positive 1, so I'm going to go over 1 and up 1 on both sides, over 2 and up 4. So it's going to look like that. Okay. Here I have a as negative 2, b as negative 16, and c as negative 30. By the way, when it's in standard form, c is going to be your y-intercept. So you're not going to see the negative 30 here on the graph, but on the others you might be able to. So x is going to be negative b over 2a, which is going to be negative of negative 16 over 2 times negative 2. So I'm going to get 16 over 4, negative 4, which is negative 4. Then I'm going to plug it back in, so I get negative 2 times negative 4 squared minus 16 times 4 minus 30. So I'm going to get negative 2 times 16 minus 64 minus 30. Negative 2 times 16 is negative 32. It should be negative 4, so this will be plus 64. Plus 64 minus 30. So 32 minus 30 is 2. So my vertex is going to be negative 4 and 2. Okay. So negative 4 and 2, my a is negative 2, so I'm going to go down 1 and over 2, down 2. And instead of going down 4, 4 times 2 is 8. So right here, and here's my graph. Now, hopefully you remember from Algebra 1 that this should be the solutions to my related equations, right? So what I mean by that is if I have 0 equals negative 2x squared minus 16x minus 30, our solution should be those x-intercepts or -5, -3. So if I was going to check that, I'm going to divide everything by -2, and I'm going to get x squared plus 8x plus 15. And then I'm going to solve that by factoring. So x plus 5 and x plus 3. And if I set each of those factors equal to 0, indeed, x is -5 and x is -3. So don't forget that the roots, the x-intercepts, are the solutions and the zeros. Okay, so just remember that correlation there. Now we can also change to vertex form. Okay, and we're going to do that by using completing the square. And here are the steps. They're kind of confusing, so let's just jump right into it. If I have y equals, or f of x equals, whatever it is, -x squared minus 4x minus 6. I can't move the 6 to the other side, or I guess I could. But what I'm going to do is I'm going to group these, and I'm going to factor things out so my x is positive. So I'm going to factor out a -1, so I get -x squared plus 4x, and then minus 6. And I'm going to leave a space here. I'm going to complete the square. So half of 4 is 2, and 2 squared is 4. Now, in order to not change the equation, I have to add the opposite over here. I've got this negative out front, so what I've added is a -4. So that means I've got to add 4 here. Okay, -4 plus 4 is 0. So we're going to do the additive inverse, so we haven't changed the equation. Now when I factor, I get -x plus 2 squared minus 2. Okay, so now it's in vertex form, and I'm going to get -2, -2 as my vertex, and it's going to open down. So over 1 and down 1, over 2 and down 4, and there's my equation. So it just depends on how you like to do it. Okay, I can either do -b over 2a, or I can put it into vertex form. Again, notice our c is -6. Here's our y-intercept. This does not intersect at all the x-axis, so there would be no solution to my related equation, or no real solution. Okay, there would be no real solution. We would have two imaginary, because remember, imaginaries go in pairs, so no real solution. We would have two imaginary if we were to do the discriminant of that. All right. Last example. So y equals 2x squared plus 12x plus 17. I'm going to group these. I'm going to factor out a 2. So y equals 2 times x squared plus 6x plus the 17 out here. Half of 6 is 3. I square 3, I get 9. Here, 2 times 9 is positive 18, so I'm going to subtract 18 here. Okay. This is going to give me y equals 2 times the quantity x plus 3 squared minus 1. So my vertex is -3, -1. And my a is 2, so I'm going to go over 1 and up 2. Over 2 and up 8. So my graph is going to look a little something like this. My solutions are almost -4 and almost 2, but not quite. My y-intercept is 17. Okay. So hopefully today you learned how to graph a quadratic in standard form, or at least reviewed it from Algebra 1, and you learned how to change a quadratic from standard form to vertex form. Have a math-tastic day.